Hey guys, welcome back. As you can see by my screen, I revisiting the Fibonacci sequence. Now, I found something out the other day. I thought it was kind of interesting, and I thought we'd try to go through and implement it together. Um, but there is a formula to find the nth Fibonacci number, and this is the formula. So, if you want to find the first Fibonacci number, n is equal to 1, second, and the first one's going to spit out 1, second one's going to spit out 1, then it's going to go 2, 3. So that's the sequence. But let's see if we can't implement something like this. And if we can, see if we can't get it working for our seeing if we can't maybe get some working for this. Now, I don't think we can for this because unfortunately, well, I guess we could. We just got to check to make sure the number is less than whatever. Is that 400 million, 400 something, 40 million? I don't know, whatever. 4 million. So the sequence of terms in Fibonacci that are less than 4 million. So we can just go through and compute, and if the number is less than 4 million, we add it to the sum. Let's go ahead and try that. So right here, we will all right, so did I close out of that paint object? I did not. There's a way for me to just keep things on at the top level. I don't remember the command. Maybe always on top. Windows Control T. There we go. All right, so now I can type in here and still keep that thing on top. So we're going to be using the square root of 5 pretty frequently here. Let's go ahead and math. Yeah, okay. We've got 3 components here. I'm thinking what we do is we just go ahead and define those outright, because I don't want us calculating the square root or 1 over the square root of 5 each time. I'd rather just have that stored as a constant. You can label these as constants instead of lets. Obviously, that would be the better thing to do, I guess. Oh wait, no, we're getting too far ahead of ourselves. 2 1 plus square root 5 divided by 2 . Okay. We've got our constants. Let counter equal. We learned from the last time that we did this that every third instance of the Fibonacci sequence is even. So we're going to start at 3 and we're going to iterate by 3. So we'll start at counter 3. Per equal want to do this. Maybe we have a function defined that we call within a while loop. Let's do that. I don't want to call this the same thing as a counter because that's going to get confusing. And we will do, what do we need? We need leg 1 times leg 2 actually just call this n. Minus leg 3 n. Okay, I think we added one too many. Yeah, okay, that looks right. This is not the most efficient way of doing this, but we are going to limit let's say 0. JavaScript and every programming language has some issues with floating point calculations, and this is going to have a floating point error in it. Almost certainly, this more certainly is going to have one, and I would be shocked if neither of these didn't have a floating point error in them at some point. To correct for that, we're going to have to do some rounding here. The floating points are usually so minuscule that math.round is going to suffice. If we're off by 1 by the end of this, maybe that's because of a floating point error, but even then, I seriously doubt it. So let's say res equals res plus get per n, nope, count. Counter equals counter plus 3. And then we'll do return res. Okay. Rather than run this whole file, let's go ahead and just put this into a code pen. this anymore. Get some. I call it 2. I should have called it 3, since that was the third instance. Get even fib sum 2. Okay. And then 1, 2, 3, 1, 2, 3. And is not defined. And shouldn't have to be defined. That's weird. Oh, right there. I think that's the correct answer. 4613732. 4613732. Wow, it's kind of cool. I mean, in this case, because of the kind of thing we're doing, we have to loop through no matter what. But if you needed to get a single instance, like if you wanted to find the nth term of the Fibonacci sequence, this is clearly the superior way. For what we're doing, I think the runtime's probably about even for larger stuff. This is probably going to run a little bit faster on the lower end because you're not doing any like square roots and division operations, which are a bit taxing, but fairly constant for us because of the way that we set it up. So yeah, I mean, but it's pretty neat trick to be able to implement something like that. So yeah, kind of neat. I'm curious as to what I did wrong when I kept on typing that in. Get even fib sum. Oh well. Yeah, I guess that's about it, folks. As always, drop a like, hit the subscribe button. Let me know if you see any cool math crap out there. I'd love to take a look, see if we can implement some sort of algorithm to make it work for us. But yeah, I guess other than that, I will see you folks around.